Welcome to Pigeon River Farm, doing farming right. I'm Robert Brown, the owner of Pigeon River Farm. Thank you for viewing. Well, good evening. In this episode, we're going to talk about, this is the third installment of the hybrid tractor build. As you can see, we've made major progress. So I want to discuss with you where we are at, and we're through the weldment and fabrication stage, with one exception to that, and that'd be the control box. But everything else is actually done. We are loaded with batteries. We're getting ready to do the cabling. So let's kind of start from the top. The tractor spent some time over by Joe's Fab Shop. A local fabricator, welder, happens to be an Amishman. Everybody's going to say an Amish welder. Yep, an Amish welder. Did an excellent job of helping develop all the different fabrication challenges we had to go through. There was a lot of things to figure out. Orientation, location, weight. So these are all critical components that had been developed. What we decided, there was two options for the batteries. So an example there is either we could go with a complete sealed enclosure. There was some benefits to that. The batteries, this is still the lead acid battery, so we're not going to really generate a lot of heat. But the decision was to go with an open architecture, mainly for the ability to clean the batteries. Because no matter how tight you see me get it, it's still going to have debris getting in there. And I thought it made more sense to have airflow on something easy to clean out between operations if chaff or dirt gets in there, than going the other way. So the battery case design is got extruded metal on it. So we have both sides and the bottom, and then the top has got the solid cover. So that was the decision that was made there. Then there's a special component that's key to it. So the removable lid, as you can see here, is got a 1/2 inch of PVC. So there's this poly PVC that's located on top, and there's some logic behind that. So we got to think about these batteries that are in here, and if, heaven forbid, the worst happened, a tractor would tip or a severe impact on the cover, I don't want to have the batteries short to ground, because this design is to have a complete isolation system. The 144 volts that's going to go to the motor will have zero connection to the chassis of the tractor. So the risk of shock is zero, unless we had a physical connection made by some type of damage. So that's why we went with the thickness and the quality of the material that goes over the top of the batteries. Then additionally, for additional protection, well, we got our double-aught marine gauge cable that'll go across the battery terminals. Then we're going to have boots, heavy grade boots that go on top of each terminal connection. Again, for that protection, to make sure that there is no risk of a short. The next challenge that we looked at, so we're going to have 6 batteries on each side, but we had to get the power from the, as you sit in the driver's seat of the tractor, the left side, to the, I guess go and say the business side, the right side. So we put a chase in other words, a 2-inch pipe that's all part of the weldment that leads between the left and right side. So there's no chance of the cables being, because there is going to be 2 high voltage cables, a positive and negative, running from right to left. We can't possibly have that take the chance of any debris getting up there, an impact, run over a chunk of tree, fence post, whatever it is, to actually go up there and penetrate it. So we have the steel tubing with the cables that run through it. So that was the next stage. The next area that was relatively complicated is developing a mounting system here for the high-powered motor. So we put this weldment here, bolts to the frame in the back, and then I didn't mention earlier, but we bolt all the way to the back where the cultivator attachment would go for the battery boxes. So you can see they're attached up here. They're attached in the back here where the cultivator mount would go. And then we are isolated, they are separate, so the battery box is separated from the motor stanchion. So we got the motor stanchion here. And then we have our belt arrangement. So we got twin 5/8 B-series belts to go onto our respective pulleys. And then you're probably catching an eye here of seeing this gear. And that was pretty ingenious. I told Joe I need to get an encoder speed of the motor. So we took a crankshaft position sensor, and that is off. And we decided to go with something that is information is readily available. So it's a crankshaft position sensor off a 2000 Chevy 5.3 liter. So it's a Hall effect 12 volt reference. So very easy to work with. And then we simply put a gear that matches the pulleys from the basically the same configuration for the swedge style that clamps on the end of the electric motor. And that is our encoder wheel. So Joe just simply took that, machined it down, adapted it, and so now we have the keyway plus we have the swedging, and the swedging or the compression of the swedge in the pulley is done by having this outer gear tooth on here, and a gear tooth of course is our trigger wheel for our encoder to know the speed of the motor. Going to be a critical component as we move forward. Next thing here is the large pulley, custom machined. I went to the original belt pulley. The original belt pulley is this component here. This was taken off. We custom machined this 16-inch twin V, like I said before, 5/8 B-series belt pulley that goes on here. And we wanted to have it very precise. So machine of the inside of the pulley, we held to basically around the thousandths. And so we didn't have any out alignment. So we wanted to run as linear or as correct as possible. So that part is done. So that works real well. I did spool it up with the motor, so driving it on with the motor side of it. The next thing, and well, let's go back to the safety discussion here. We put in latches on the side cover. You can see the nice little slides. This comes out here. But the latches were put on specifically, and we will put locks on here. And the reason is I don't want anybody in here because of the high voltage. So usually kids will listen when you tell them, but adults won't. So my thought is I don't want to have anybody in here that's not authorized. So we will have a set of keys and 2 locks on each side. So it was a small ingredient, but I think a critical ingredient. I've done a lot of EV cars and hybrids, so I've been around the batteries, and I know the risk. I've been trained on it. I went through the Toyota training, Toyota and Lexus, so I know the training very well. So the thought is, this is the same potential. Doesn't matter if it's a high-end lithium ion or a lead acid, doesn't matter. 144 volts is 144 volts. So we want to make sure that nobody goes over the edge with that. So that's going to have the control. They come out of here real easy. Just bring up the point again. Here's the poly, the PVC that we have on the bottom. Okay, nice precision closing. The motor is securely mounted, and if you recall, the motor came with this weldment on it for its original configuration, and then we will be putting in a additional control box. And let me show you what few of the items that are going to need to go into that control box. First item is they're going to be our high voltage controller. This is going to control the speed of the motor, the torque of the motor. This is really the brains of the operation. We've got to connect to these very large bus bars. Then we got our high voltage relay that's going to have to fit in the box. And then we're going to have another custom controller that my dear friend Eric is working on, and that's going to be the interface to this, and that'll use the encoder so we can go from what we would say a foot throttle operation to a governor operation. In a governed operation like a tractor here, you're going to do a fixed throttle and then you anticipate different load configurations. So that's going to be the thing. Unlike your car, when you're driving your car, you are going in and you're pushing the throttle up and down to maintain speed unless you engage a cruise control. In the sense, a cruise control could be called a governor. So it's going to maintain a given speed. We want to achieve something similar, so that's why the encoder and then the feedback to the controller is going to be critical. That is going to be the next stage we're going to be working on. So right now, I just wanted to just we'll kind of end it here and talk about the weldments. So Joe did all the welding, all the fab, as you've seen. Everything was shipped out to be powder coated. Instead of painted, I wanted it powder coated so it would take a lot more. It has a lot more durability and take a lot more abuse. And I'll bring this point up into the future, but the plan is to get it all together, functional, because it is a prototype engineering project. Get it into that functionality, try to get some of the bugs worked out of it. Winter, you know, it's hot, middle of summer, hot as the blazes out there, but winter's coming, so shop doors will probably be closed again. And what we'll want to do at that time is everything's going to get disassembled and the tractor is going to get the paint job at that time. So I'll have a chance to go through. We got some hydraulic configurations we have to figure out because remember the engine won't be running. So plan is we're going to be rebuilding a belly pump for this that one was taken out. And so that's going to have to be integrated into the distributor drive pump. So I'm going to have a little bit of controls for the hydraulics also. So always these little challenges you have to deal with. So I hope this brings you up to speed to where we're at. We will be working, the next phase is going to be the cabling and getting the controls, all of that figured out. So if you have any questions, please message me and hope you enjoyed the video. Have a great evening.